In the last video, we derived the quadratic equation, which is right here on the bottom. Now I want to leave it in vertex form so that we can look at other things. Let's see what that looks like. So we're going to make sure this is centered. Okay. So we can pick it up. You know, if you didn't see that video, well, I suggest you go see it. Unless you can go, we can go through this very fast. I'm basically writing the standard form of the trinomial polynomial, and I'm going to follow the finding the perfect square procedure, which means that we have to first we have to get rid of the a, so we divide everything by a, and that's what this looks like. Then we have to find half of BA, which is BA divided by 2. Then we put a 1 underneath the 2, and we flip it like this, and then we get B divided by 2A, and so we have to square that here. Then we have to subtract the same amount, yeah, and then we have our C over A equal to 0, yeah. Then we move over here, and we can change this into our perfect square, yeah, and we have to solve this stuff here, which is right there. That is equal to b squared divided by 4a squared plus c over a equals 0. Yeah. Here I kind of make some kind of mistake because I was not following the procedure, and I made a mistake, so we can neglect that. We come from here to here, and in here, let me see if it's centered. Yes. We write the perfect square with the 2 there, and we move this on the other side, which is here. And then we take the square root, of both sides. This 2 goes with the root, and we got left with the square root plus or minus the square root of b squared divided by 4a squared minus c over a, which can be written as this by finding the greatest common divider, which will be 4a. Then you divide 4a divided by 4a squared is 1 times b is b squared, and then you divide 4a squared divided by a, then 1a falls out, and that's why we get 4ac. And that is what's in here. Well, not quite, but that's because it's on this side of the, when we move it to there, then this changes sign. And that's why it's plus b minus 4ac divided by 4ac squared. But we can take this out of the root, and so we becomes 2a, because one of this the 2 goes with the root, and square root of 4 is 2, so we get 2a. Yeah, and then we have this term here, which is 2 divided by 2a, which we're gonna move to the other side, which we did. And so, and then these are 2 common, so we put it on a single line there, the divider line, and so we get this the formula, the quadratic formula. Okay, now what I want to do is from here, I'm gonna go there. I'm gonna rewrite that on the next paper. And so we have x plus b2a squared, and we have minus b, well, we have that one, b squared plus 4ac divided by 4a squared. So okay, so what can we do here? We can separate this, maybe. Just write it as b over 2a. Well, the negative sign stays outside, and we put a square there, and this turns into plus what is it, c over a. Yeah, and the vertex formula is equal to a x minus h squared plus k. Which means this is correct. Wait a minute. Is that true? Let me see. Let me think a little bit. Okay, I got it. The idea of here is to come up with formulas to do the vertex really fast, because h would be equal to let me see, h would be equal to well, it's got to be b divided by 2a, which is correct, but the minus sign where's the minus sign come from? I think that to derive, because we are looking for a formula, we can take what's inside over here, and we said x minus h equal to 0, and said x is equal to h, right? Which is here. So, but in order so if we substitute h by b to a, and we put it back in the formula, then we get x minus b to a. And that's where the negative sign comes from. Yeah? So we have to put a negative sign there. Remember, we're trying to create a formula to find the vertex really fast. And we're going to test it. When we finish, we test it. And then for k will be equal to this thing here. Right? If our leading coefficient is equal to 1, right, which most polynomial have, most of the problems that we see, we'll assume that, but we'll make a general formula anyway. But in case that in the case that a is equal to 1, then this will reduce to minus b over 2. The h will be, that's what h will be equal to. And let me see. Yeah, no, yes, okay. And k will be equal to minus b divided by 2 squared plus c. Okay, so let's test it. So we take x squared plus I'll make sure that this is not a perfect square by finding the perfect square. The perfect square will be plus 4 if I put a plus 4 there. So I'll put plus 6 equals 0. So we want to find the vertex with using formulas. So we say, well, h is equal to minus b divided by 2. Yeah, minus. So then this will be equal to minus 4 divided by 2 is equal to minus 2. Yeah? And k will be equal to, where's k? K will be equal to minus b, which b will be 4 divided by 2 squared plus c, in this case c is 6. So k will be equal to 4 times 4 is 16, and 2 times 2 is 4, plus 6. So k is equal to 4 minus 4 plus 6. K will be equal to 2. Now we're gonna do it the regular way of trying to find the perfect, let's do this problem here, and we'll write the x squared plus 4x plus 6. So we're gonna find the perfect square, so we rewrite this as x squared plus 4x, and half of 4 is 2, squared is 2 squared. So we add we subtract 2 squared, and we add 6 plus 6. So I hope that you can see that, yeah? Okay. So what do we have? We have, then we, at this point, we can change this to a perfect square, to a perfect perfect square. And so this will be 2 squared, and this thing here, this mess here that you can't even see what the hell it is. Okay, it's 2 squared, 2 squared. You have 2. Okay, this stays. So it's minus 4 plus 6 is equal to 2. So k will be equal to 2. Jesus. And that's equal to 0. And so from here, a is equal to 1, which is correct. From there, h is equal to minus 2, which is correct. And k is equal to 2, which is correct. So, you know, that's it. So if you want to find the vertex of the vertex form of a trinomial polynomial using the formulas, and you have them there, you know. So we can probably rewrite the equation. No, not really. We don't want to rewrite anything because it will be a mess. What the hell? Why the computer turned off? Uh-oh. The computer just went off. Or it logged out. Anyway, no biggie. In any case, that's it. So, conclusion, for a equal to 1, h will be equal to minus b over 2, and k will be equal to minus b over 2 squared plus c. And that's it. And it works because we tried it and it does work. So I hope you like that. In some schools here in Germany, they teach the kids. They teach the kids to use this formula, but they don't use B's and H. They use P and Q. And I have it somewhere, but I have to find it. Let me pause the video. Here it is. Here it is. You can see that because they write the equation, you see they obviously assume that a is 1 because for kids, they don't want to complicate the thing with having a coefficient, a leading coefficient that is non-1. So assuming automatically that a is 1, then they use P instead of B and Q for C. And so when you do that, you can see that the formula is exactly the same. You can see that P divided by Q, which I have, B divided by 2. And so you can see that they write it the same way, you know, minus P divided by 4 plus Q. This is exactly the same thing. But instead of using this is B and this is C. So if we replace the P's by the B's and the Q by the C, is exactly the same. And so the standard form, you can find H by minus P over 2, and K is equal to minus P squared over 4. Instead of writing it like I wrote it, like I wrote P over 2 squared and put minus, the same thing. And so that's it. You know, that's it. I hope you like that. Like I said, this is in Germany. They use P's and Q's. I don't know why they do that. I think it's not fair. Well, maybe if you speak German, you'll understand why they use P and Q. I don't. I swear I don't. I never asked, never tried, haven't done anything. So that's it. I hope you like it. Take care. See you next video. Don't forget to subscribe to my channel. Leave a comment. You can share if you like. You can hit the bell if you like. That's up to you. Okay, thank you very much. Take care.